Okay, in this video, we're going to learn how to do empirical formula calculation from mass numbers. So the purpose of doing empirical formula calculation is because when sometimes people obtain a new compounds, like brand new compounds and ever been discovered, the only information people may have in hand from the experiment is the mass composition or mass numbers, like in what's been described in this question. So in this example, people find that there's a compound that's composed by two elements between iron and oxygen. And the information they have, they don't know the formula. So what that means is the ratio between x and y, or those two numbers they don't know. There could be a 1 to 1, could be 1 to 2, 2 to 3, but it's unknown. That's what we're trying to find out. That's the empirical formula calculation is about. Now, what's usually available to you is we know how many grams of each element. Okay, keep in mind this is the mass number of each element. Okay, if there are 3 or 4 elements, you need that number for each one of them. And then people will use this information to calculate, to find out the empirical formula, to basically find out the x and y little numbers here following this look like fairly fancy protocols. Okay, but we're gonna go through each step, and then it's not as bad as it looked like. Okay, now first of all, you need to obtain the mass of each element, which is what you already have. Now step 2 is going to be from the mass number of each element, you can obtain the number of moles of each element. So this is something we've learned before. Okay, for instance, for iron, it's going to be 11.57 grams iron. We need to know how to convert this into mole by dividing this, do the conversion we've done before. Gram of iron down here, mole of iron up here, and then cancel this. Okay, and 1 mole on top, 55.87 at the bottom. That's the molar mass, and you're gonna get the number mole. So you see, usually when people put out the list of the things you need to calculate, first of all, you start from mass number, okay, given, and you're gonna obtain the mole number from there. That's 0.207, and that's the mole of iron. And you're gonna do the same with oxygen, 4.43 times 1 over 1 grams mole of oxygen. Down here, gram of oxygen, that's 16. Divided by 16, that's going to be 0.277. Okay. Now these are 2 moles. Okay, moles number. Now between these 2 mole number, or if you have more than 2 elements, you need to keep calculating the mole number. The only thing I want to highlight here is you're dividing by the molar mass, different molar mass here, obviously, because you're doing with different elements. Okay, number 3, divide the number of moles of each element by the smallest number. So once you calculate the number of moles, okay, there'll still be some number higher or lower than the other number. Identify the lowest one. Okay, between these two, it's going to be this one. Now you're going to divide everybody by that number. So you're basically going to divide 0.207 over 0.207, divide by 0.277 over 0.207 as well. Once you divide by the smallest one, of course, if you are dividing by yourself, you're going to be 1. Or if you're not dividing by yourself, divide by some number smaller than you are, then you're going to get a number greater than 1. Like in this case, you obtain a number 1 and a 1.33. Now it's just a matter of converting both numbers into whole numbers. Okay, multiply to get whole numbers. Depends on, obviously, 1 with number 1, you can divide and you can multiply it by any number. Okay, it doesn't really matter. But with 1.33, you have recognized that 0.33 is the part you want to convert into a whole number by multiply by 3. And then keep in mind, if you multiply this number by 3, you need to multiply 1 by 3 as well to maintain the ratio unchanged. Okay, and once you multiply both numbers by a certain factor, in this case 3, you can obtain number 3 versus 3.99, and then you can easily round them to a whole number 3 to 4. So in other words, now these x and y here, you just obtain the whole number ratio, and their simplest whole number ratio to be 3 and 4. Alright, a couple of things I want to highlight here. Okay, 1, when you obtain the number mole, you make sure you divide by the molar mass of that single element only. Second of all, when you multiply by a certain factor, okay, keep in mind, you need to try to focus on the fragment part only. and make sure you multiply all of the numbers by the same factor. And when it comes to rounding, it should be fairly straightforward, and make sure you know which number goes with which element. Okay. All right, let's take a look at another example. Now, what is the empirical formula of an oxide if 1.40 grams of nitrogen is reacted to form 3.8 grams of oxide? To form a 3.8 grams of oxide. So feel free to pause the video here, see if you can figure out the some kind of work by yourself. Okay, and then we'll definitely work out together. All right, so let's say you already tried something here. We're gonna do a very similar thing, okay? The only thing that, or I wouldn't say tricky part of this question, or I want to address before we start doing things, is that you have to read the question carefully, okay? For example, this is about between nitrogen, we're trying to figure out a compound composed by nitrogen and oxygen. We're trying to figure out, what little numbers goes here. So what we need is the mass of nitrogen and oxygen as two individual elements. So we need to get the mass number. Now, if you read the question carefully, you will see what is empirical formula of an oxide if 1.4 grams of nitrogen, so that's the mass of nitrogen, is reacted to form 3.8 grams of oxide. See, this 3.8 grams is not actually the mass of the oxygen. It's the oxide that's being formed from the reaction. So that means the total compound, okay, mass is 3.8 grams. And there are 1.4 grams of nitrogen in it. So if you want the mass of oxygen only, you need to take 3.8 minus 1.4. And this is going to be a lot of cases will be like this, okay? You have to take the first element out from the compound to get the mass of the second element. Okay, so you can imagine if you didn't do this subtraction here, and then the rest of your answer will be wrong. Okay, if you did that, you can pause here to redo the rest of the part. All right, so the next step will be converting both mass numbers into mole number. Now, the mole of nitrogen is going to be starting from 1.4 grams divide times, find the molar mass of nitrogen, it's going to be 14. So that's going to give you 0.10 mole. Okay. Now for the oxygen, it's going to be 2.4 grams divided by, multiplied by 1/16. We're going to have grams at the bottom, right? And mole on top. And that's going to give you 0.15 mole. You might notice that I wasn't paying too much attention about the sig figs, because at the end we're going to round everything to a whole number. Okay, as long as you keep reasonable number of sig figs here, it should be good. Okay. All right, so these are the moles. The rest next is between these two numbers, you need to find the smaller one, and that's right, it's 0.1. So divide by by 0.1. Divide both numbers by 0.1. So this divided by 0.1, this divided by 0.1. You're gonna end up to be 1 to 1.5. Okay. Now next is gonna be multiply a factor to convert both numbers into whole number. You have to multiply by the same factor, okay? And it's not hard to see that 1 is okay. It can multiply anything. It's the 0.5 here. You need to, in order to multiply a smallest multiple of 0.5 to get the whole number, obviously that's going to be 2. So multiply by 2, multiply by 2, so you can have 2 and 3. So in other words, the empirical formula of this compound is going to be a number 2 next to nitrogen, a number 3 next to oxygen. So it's going to be 2, 3. Okay. All right. So let's look at one more example. Okay. In this example, you can see you're not given the actual number of grams, but instead of percentage number. I just want you to know that they work the exact same way as the mass number. Okay, as you can see, the formula or the mass composition of the formula, they are independent from the absolute amount of the sample. Whether you have 100 grams of this, or you have 1 gram, or 1,000 grams of this, the mass composition of the chemical or the chemical composition of the chemical, they are not going to be different. So you can easily imagine that if you have percentage number for each element, okay, so you just imagine that if you have exactly 100 grams of the total compound, then that makes these numbers are number in grams. Right? If you have 100 grams of this compound, you would have 36.2 grams of sodium, 25.3 grams of sulfur, and 38.5 grams of oxygen. So you can just use them as number of grams. Remove this percentage symbol. The other thing is that if you are given percentage number, okay, and sometimes problem may give you a percentage number of 2 elements out of 3, and you have to know that the last one can be calculated by subtracting the percentage of the other 2 elements from 100% to get the percentage of the third element. Okay, just in case something like that. All right, so the same thing. We're going to list out 3 elements instead of 2. And then we're going to write down the mass number. In this case, like I said, these percentage number are as good as any mass number. Okay. Now, next thing is going to find the mole. Okay. Feel free to stop, pause at any time to try yourself. Okay. To find the mole of each element, make sure you divide by the molar mass of each element. Okay, these are the molar mass. This is 23 is the molar mass of sodium, 32 is the molar mass of sulfur, 16 is the molar mass of the oxygen. So make sure you divide by the molar mass of this particular specific elements. Okay, so once you divide 36 over 23, you're going to get a number like 1.574. And 25.3 divided by 32, you're going to have 0.791. And 38.5 divided by 16, you're going to have 2.41. Okay. Now, you got 3 number moles. You're going to divide everybody by the smallest one. So you're going to divide everyone by the smallest one, obviously the middle one, 0.791. So if you divide first number, 0.791 equals to 1.95. And 0.791 divided by itself is going to be just 1. 2.41 divided by 0.791 is going to be 3.04. Okay, and now these numbers, they are not whole numbers, wrong. Usually these numbers, they are not going to be exact whole numbers, but they should be really close to whole numbers. So it's not hard to round them either up or down to a whole number. So you can write out the formula as sodium 2, sulfur 1, you don't need to write any number, oxygen 3. So this is the compound. Or you can quickly name this compound sodium sulfite. Okay, so this is the empirical formula calculations you starting from either mass number or mass percentage number. Okay. Now, just a quick summary. Okay. Key thing is you want to get the mass of each single element first, and then obtain the mole of each element before you divide by the smallest one. Okay.